This lesson is just a review of lab safety. So, we've already looked at the lab safety rules and we've talked about those in class. But what I want to do is I want to focus on some specific things that are important for you as a chemistry student so that when we are doing our in person labs, you will make sure that you are following all safety guidelines so that you are safe and your lab partners are safe. So, let's get right into it. Very important that you always wear your personal protective gear. Always wear your safety goggles in the lab. Now, in chemistry, we use splash goggles, something to protect any liquid from coming into contact with your eyes because we use a lot of liquid or aqueous substances. And so you can't just use impact goggles or eyeglasses or sunglasses. They're not adequate substitutes. You need chemical splash goggles. Now, just a little warning, this is not the prettiest thing that I'm fixing to show you, but I want to show you what a chemical burn to the eye looks like. This can be prevented by wearing your goggles. So you see here in this central area here, this is where the chemical landed, and of course all around it you see there's a lot of irritation, but this is a burn to the tissue here, and anytime that chemical comes in contact with the eye, especially if it's a strong acid or strong base, a very irritating substance like that, very caustic, it can cause irreparable eye damage. So always, always, always wear your protective gear. Your eyes need to be covered. Long hair. If you have long hair, guys and girls, you got to pull it back. Okay, so always tie your hair back with whenever you're doing lab so that your hair doesn't get into a chemical, so that it doesn't catch on fire, or that it doesn't, if you were to lean over and maybe potentially bump something, knock something over as well. Another important rule is you don't want to clutter up your desk areas. So in the lab area, you don't want to take backpacks and purses and books and things that are unnecessary to your lab area. Keep your lab area with only the bare essentials, what you need for the actual lab itself. Now, inside any chemistry lab or any lab setting for that matter, you need to know the location of the following pieces of safety equipment. Your eye wash. So when we get back to in-person class, I want you to take note of where the eye wash station is. In case you were to get something in your eye and you would need to rinse your eyes out, you would be able to get immediate first aid. The fire blanket. If there's a fire, you want to know where the fire blanket is. So the fire blanket is used to put a fire, maybe if your lab partner's clothing or hair caught on fire, you would want to get the fire blanket out of its container, and you would want to smother the area that was burning so that the oxygen is depleted and the fire would be extinguished. So fire blanket. You need to always know where that is located. You also want to know where the fire extinguisher is. The fire extinguisher would not be used to put a fire out on a lab partner, but you would want to use the fire extinguisher if, for example, something at your lab station caught on fire. Let's say there was a fire in the trash receptacle, an electrical fire. You would want to use the fire extinguisher. Now, there is a very important acronym to remember with fire extinguishers, and the acronym is the word PASS, P-A-S-S. So the PASS acronym helps you to remember the four basic key steps to using a fire extinguisher. We're going to talk about that. P. P stands for pull. I'll put this underneath it, P-U-L-L. You may want to write this down on your lab safety rules, this part here. You need to know what PASS stands for. Pull. So what you're pulling is the pin. So in the fire extinguisher, there is a pin up here at the top. It's a cotta pin. And if you pull it out, you can then squeeze the handle here together and you would be able to spray. But the P stands for pull the pin. And then the A stands for aim. Obviously, if you're going to put a fire out, you got to aim at the fire. So you would aim the hose here at the base of the fire. You would then, once you pulled the pin and aimed it, you would then be able to squeeze the handle up here. So the first S stands for squeeze. And then as you're squeezing it, the chemical, it's a dry chemical, would come out of the fire extinguisher, and then you would be sweep in a sweeping motion, S-W-E-E-P. You would sweep um, the hose and spread the chemical over the fire in a sweeping motion. So remember, for how to use a fire extinguisher, the acronym PASS: pull, aim, squeeze, sweep. Obviously, in a science lab, you don't want any horseplay. So here we have this family of horses with a little kid horse, little colt, and it says all set for a fun day at the pool. And then they saw the sign, no horseplay. Darn. Oh man. So anyway, little corny humor there for that. But in a lab, you don't want to play around. There's no horseplay. Is it okay to, when it's appropriate, to joke around and be lighthearted? Of course. But when you're in a lab, you don't want to play around with the chemicals. You don't want to play around with any of the equipment. You want to follow the directions so that no one gets unnecessarily hurt. You never want to perform any unauthorized experiments. You could have a pretty bad explosion. You never know what kind of reaction may occur, what type of fumes may be given off. So never perform an unauthorized experiment. Never go online and look up how to blow up this or how to do this or that, because you never know where the source of that came from, the source of your article that you found. And you also never know what types of substances would be formed in that particular chemical reaction that could potentially be deadly. So never perform unauthorized experiments. Okay, no food or drink in the lab. We talked about this already. You never want to have food or drink in a lab, in a chemistry lab especially, because you're going to have chemicals around. And if you have chemicals around, the chemicals could potentially contaminate your food or your beverage. And then therefore, if you're eating, you could potentially ingest it and then become very, very sick. And or, worst case scenario, it could be something that could be toxic and could kill you. So never, ever, ever eat in a science lab. You never want to remove chemicals or equipment from the lab. Of course, that's stealing, number one. Number two, you don't want to take those and just play around with them and thinking, oh, I'm going to go home and I'm going to duplicate what we did in class today. You just don't want to do that. That's a big no-no. So do not ever take chemicals from the lab by stealing them without permission. Next slide says never, never ever use chemicals from an unlabeled container. Now, over here, this container, this big, gigantic bottle you see here, notice there's no label on it. Now, I know because I'm a chemistry teacher and I have been in our stock room, I know that this container contained sulfuric acid or nitric acid or hydrochloric acid, okay? Because these are the kind of bottles that the strong acids come in. But there's no label here. So you would never want to take a chemical from an unlabeled container because, in honesty, all acids look like water. They're clear. They're colorless. And you would not know that it wasn't water. So you never want to just take a chemical out of a container and just assume that it's a particular substance. Always make sure that you label your containers when you take a chemical and put it in it. And also make sure if you're getting a chemical, you get it from a labeled container. Now, since we're talking about acids, I do want to talk about the proper way to safely dilute an acid. This is the second thing from this presentation that you definitely want to write down. So, two things you want to write down, and I'll tell you where I would write them. I would write them on your lab safety rules, or you can just put them in your notes if you don't have your lab safety rules handy. You want to write down the acronym PASS, pull, aim, squeeze, sweep. You need to know that. That's how to use your fire extinguisher. And you also want to write down this, how to safely dilute an acid. Now, to dilute something, think about what that means. If you have something that's diluted, that means that it's weakened. And normally we dilute things with water. So we would be diluting an acid from a high concentration to a lower concentration by adding water to it. But with acids in particular, and this is again where chemistry and your knowledge of chemistry is important, there's a certain order that you would want to mix the acid and the water together. So notice what I have here in quotes. It says, do what you oughta, pour the acid in the water. So I tried to make it rhyme a little bit, so you got to say it with a little southern twang. So do what you oughta. What does that mean? Do what you should. Do what you ought to. Pour the acid in the water. Oughta and water. Do what you oughta, pour the acid in the water. You always pour the acid into the water. You never do it the reverse way. You never pour the water into the acid. So just remember, if you were to say it the reverse way, it doesn't rhyme. Do what you oughta, pour the water in the acid. That doesn't rhyme. But do what you oughta, pour the acid in the water. That rhymes. So you always pour the acid into the water and you slowly stir it until it's diluted. Now, the reason that you do that is because when you dilute an acid, it is a very exothermic process. That's something we're going to learn about in this unit, actually. Exothermic, it means that it releases heat or energy. And if you do it in the wrong order, then it could release enough energy that it could potentially get hot enough that it could boil, or it could break the container. If you have it in a glass container, it could get hot enough that it would crack the container, and then it could possibly get on you. So you don't want to ever dilute an acid improperly. You do what you oughta, pour the acid in the water. Acid in the water. Remember that. Very important. All right, next thing, heating test tubes. When you are heating test tubes, if you're in the lab and you're trying to heat a test tube, you never, ever, ever want to point the mouth of the test tube or the mouth of an Erlenmeyer flask, if you're heating that, at yourself or at another person, because the substance you're heating could get hot enough that it could shoot out of the top of the container, and then you would have basically a very hot liquid in someone's face or on somebody. So never point it towards yourself or another person. Point it away. Always direct the mouth away from people. So here in this slide, we see a little picture of Barbie looking straight into the test tube. That is wrong. Bad. Don't do that. Barbie could have burnt plastic face. Instead, you would want to point it up, or I would even say point it away at an angle away from her. That would be the proper way if you're heating that. Do not ever point it towards your face. Of course, you should have your goggles on. She does not have her goggles on. But besides that, it would burn her skin. You could have a bad acid burn on the skin. You never want to heat a closed container. Notice this picture shows a stopper on top of the Erlenmeyer flask, which is on a hot plate. So if you were to heat this up, obviously if there's a liquid in here, it's going to start to boil. And as it boils, what's going to happen is the gas pressure will build up, and it could make that stopper go flying off in any sort of direction, and it could hit someone, possibly in the eye. Or let's say you had that stopper shoved in there really tightly, but the pressure built up, it could shatter the glass and you'd have glass shards everywhere. So never ever heat a closed container. You could have an explosion. Keep flammable substance away from heat sources. You don't want to have a flammable hydrocarbon, an organic substance, around an open flame, because you could have a potential explosion there. If you have a spill, please clean it up immediately. Never return a spilled or unused material to any reagent bottle, which that means don't put it back in the bottle you got it out of, because you don't want to contaminate the original bottle or container of substance. Solids should be swept up and placed in the waste disposal container for the lab. There's always going to be a waste receptacle for any solid. Small liquid spills should be diluted with lots of water, and then mopped up with a cloth or towel. But if it is a large spill, you got to make sure you let me know, let your instructor know, and I will handle it because there may be special ways or means by which to dispose of it if it's a very large spill. Anytime you get injured, it's important that you begin first aid immediately. Alert me, alert the instructor. If the chemicals have come in contact with your eyes, you need to get to the eye wash immediately and take your goggles off. If you didn't have your goggles on, that's number one, the problem. That's a no-no. But take your goggle off. If it gets on your eye or maybe somehow maybe got behind your goggle anyway, begin washing immediately. Don't try to cover it up and think, oh, Miss Tanks, I'm going to get in trouble if I tell Miss Tanks. No, you need to get your eyes cleaned out. You do not want to risk blindness. Remove any clothing that has been contaminated with chemicals. So if you get a chemical spill on your clothing, you want to get the clothing off of your skin because you do not want your clothing to keep the chemical directly in contact with your skin. You got to get it off. Get the chemical and then rinse the chemical away. Move everyone away from the area to avoid further contamination. And again, as I said, report all injuries to the instructor immediately. Always report any kind of injury, burns. If you cut yourself, whatever, chemical in the eye, you need to report it to me immediately.